Thank you so much for coming. So yeah, a bit about me. My name's Jade. I'm a software engineer from London. I got really interested in optimizing code at my second dev job, and that's been an ongoing interest since then. This is me back at home with my dog, Cubby. She is a Shiba Inu. So I'm going to start out with a bit of background for this workshop, and then we'll look at how to find slow pages. And then we're going to investigate why they're slow, and then at this point as well, we'll have the exercises. So this workshop is called How to Use Flamegraphs to Find Performance Problems. But first up, a bit of background. Let's think about why we actually care about the performance of our applications. So firstly, a website that loads more quickly has a better user experience. You don't want to sort of just be waiting around forever for something to load. The impact of this for customer-facing pages is that slower load times tend to decrease conversion rate at the point where you've got issues of conversion. The easiest way to get a read on this is if you've got pages that are slow in your sales funnel or sign-up process to measure the sort of dropout rate on those. Cool. So the next thing that performance is relevant for is server costs. So if you have slow code in more heavily used areas of your site, then naturally you're then going to have higher server costs. So if you can make that code faster, then the impact will be to sort of lower those costs. As well as this, if you have performance problems in your system, then eventually under peak traffic, peak load, you're going to have errors. I'm going to talk more about this in the second half of this workshop. At this point, I just want you to sort of bear this in mind, basically. So this is my dog in profile. Let's talk about why we need to profile applications. So we need to get a realistic view of what is causing slowness. So for speed, intuition can sort of fail. You might have had the experience that I have had of reading some code and thinking, oh, I bet that's going to be really slow, and then it's actually not at all. We also might not, for those reasons, catch slowness in code review. And also, because products can slow down as they get more successful, you are not necessarily going to see slow code being slow immediately. Like, the point at which it becomes slow is going to be ahead of that merge, really. After that merge, sorry. So you could ship something that works perfectly well with a couple thousand rows in your database, but it could start slowing to a crawl when that scales to like 100,000 or 1,000,000 rows. So we want to get data on what part of the page load makes it slow. So I talked a bit about why we need to profile applications. Let's talk more about tools. So many of you will know this. We use something called a profiler to collect profiles of all code that's run on your server when loading a page or calling an endpoint. And what a profiler does is it tells the computer to stop what it's doing for just a second and say what it's up to. So you might say oh, what are you up to now? And it says, okay, so I'm in the middle of initialize method, or oh, I'm making a database query right now. So this happens over time throughout the operation. It just keeps asking for the stack frames, the details of what's going on right now. And then these are collected up into something called a profile, which is what we use flamegraph tools to visualize. So some common Ruby profilers include RBSpy by Julia Evans, RubyProf, StackProf, and RackMini Profiler, which is what we're using throughout this workshop. So we've covered the why. Let's take a look at the how. So this is what you're here for, essentially. The first thing is that for any performance work like this, I would say, realistically, you're going to have limited time to do this. So you want to focus your efforts on where they're really going to be useful. You can follow an elimination process to find causes of slow code. And then any code change you make locally, you measure the result of that change on your machine to see if you sped things up, made no impact, or sometimes, to be frank, slowed things down, at which point, please don't merge that. So yeah, you follow an elimination process. I've gone backwards. And then once you've made that change, you raise a PR and you want to test the impact of that change in production in case it's different in a bad way. So yeah, prioritizing areas to speed up. To prioritize areas to speed up, you want to find pages that are both heavily used and slow. So say you skip ahead a bit, and you just imagine for a second that you've already raised a PR speeding up a page. You want to be able to say on that pull request why, not just what you did, but also why you've done that. This might not be super clear to people. Like, if it hasn't always been a priority to have pages load quickly, which it should be, but now it is, then that won't be necessarily clear to people. So I do want you to be very confident in explaining why you're improving something. Not just like, oh, I thought it'd be cool. So yeah, the reason I say this is, as I kind of hinted at, you've probably got a lot of other work to do on your team. So you want to be looking for something that is not too optimized, that is not only heavily used, but is also slower than it could be. So it takes up too much server time. A bit about the impact of speeding something up. If you say you find that one internal report that's generated once a month by hand, by one person, using your software, if that takes 100 seconds to run, I wouldn't start by speeding that up unless that somehow becomes a priority. On the other hand, if your homepage or your payments pages are taking 100 seconds, please speed them up, definitely. And also, you want to think about the context of the business that you're in. So I've put some examples here on the 4th bullet point of pages that are generally key. I've seen this in a couple of places. If these are slower, these pages, it's going to become a problem. Actually a business problem, not just this is uncool, we should make it faster, but it's a problem for your work. And you can also think about, I suppose I've said customer base, but I really mean the user base. So can you rely on one type of user continuing to use the site, but not another? So the example here I'd give was if you've got an internal admin application. It sounds bad, but internal admin users can tolerate slightly slower load times than customers who haven't signed up yet, because they can go switch to another tab and just look at your competition if they get bored waiting for your site to load. So if that's happening in your sign-up or conversion process, that's pretty bad. And this would all inform your prioritization. Most of this is very dependent on the business that you're in, but what is going to hold is how you find those pages that are taking up the most time. So let's have a look at that now. So you want to put together an ordered list of the kind of worst offenders. And to do this, you want to look at real results for real users. You can do that with a tool like New Relic. So you go in New Relic or whatever APM you're using and look at web transactions taking the most time. The reason I'm saying look at web transactions and not non-web transactions is that if you've said we are going to process something in a background job, you've already decided you don't need that to complete immediately, whereas the stuff in web transactions you effectively do. So I'm not going to go into New Relic right now. Instead, I've picked out some examples of lists of most time-consuming endpoints. So this is a factor of how often these get called, and also the amount, how when they do get called, how much time they take each. So I just want to make a point that the endpoints are ranked relative to each other. So the costliest action from the middle diagram, for example, could be faster than the 4th costliest on the left or right. You may find after putting together your rank list that when you actually look at the average response time, it's not that slow, it's just called a lot, for example. So then you can also think about what will have the highest impact from your product and start there from that list. And you might want to think about this from an architectural perspective, if that is relevant. So if you've got a bunch of services, and one is the upstream application, or the one where sales happen, you might think about that as well. So you've got your list. You will now want to work your way down that list and work out where the time is being spent. If you've got a New Relic, this is quite straightforward. I think Scout APM is also good, and it's free for open source projects. So if you've got a public repo on GitHub, I think it's free. I would double check that, but I think at last time I checked. So for when there's time spent in the front end, you're all probably using different frameworks, so I'm not going to cover this. However, you can be in a situation where you spot that your back end is very fast, but your front end is slow, and that is just as important. This would be a very long workshop if I tried to cover every one. So instead, I've put together a bunch of resources which you can dig into for your particular framework, and I'll share these at the end. You can also use flamegraphs in backend languages other than Ruby. They didn't originate in Ruby, so I'm going to share resources for those if you want to look at that a bit more. I'm also just telling you everything I'm not going to do in this workshop. So I'm also not going to dig into database performance. Again, you could be using Mongo, you could be using SQL, you could be using multiple options. For the purposes of this workshop, we're going to skip over that entirely. So yeah, let's look at how we can find where in the backend is responsible for slowness. We are going to use Rack Mini Profiler to do this. So yeah, the first exercise is to check it's installed and working okay. So yeah, if you've done the setup, you're ready to go. If you haven't, it might be a good idea to see someone who has. This is really about recognition at this point, so kind of like, hopefully, you'll have access to something that's running. So yeah, I want you to start up your server and go to localhost 3000 in the browser. So once you've done that, can anyone see anything extra on the page you wouldn't expect to see? Has anyone got it running? OK, great. Can you see anything you wouldn't? Oh, sure, go ahead. Oh, yeah, sure. Yeah, sure. So they're on, hang on. Oh, that's not. Is this? Can you see that OK? Has anyone got it running? OK, great. Can you see anything on the page you would not expect to see? Yep. Yeah, great. So you should see a little badge at the top left of your browser with some boxes, each reading out a millisecond value. I'm going to show you it, so if you haven't got things set up, don't worry. This badge, so if you run your app with Rack Mini Profiler switched on, you're going to see a badge in the top left. When you click on it, it shows you where the time is being spent on your page and what database stuff is happening. So this is actually, I said I wasn't going to talk about databases, but I just want to make a point that though this table says SQL, it actually works for all active record queries. So this diagram is an example of it showing Mongoid queries. It just says it's SQL still. But yeah, this is a different topic. Let's talk more about the flamegraphs tool. Yep, so Rack Mini Profiler has a very good flamegraph tool, which you can use by adding the query parameter pp equals flamegraph, question mark, sorry, pp equals flamegraph to your query string. And it gives you a flame graph of what happens when you load your page. So the way it works is, in the same way I talked about profilers working, every millisecond or so, it sends a signal to your Ruby process to interrupt it, and then it records the current stack, and then it squishes them all together, and then it visualizes that. So the height of the flame is how deep we are in the stack, and at the bottom, you're going to see stuff like Ruby or Puma, like the very base stuff. The x-axis on this flame graph represents time, and you can also click on any part of the graph to see what line of code has been reached at that point, and all the code that it calls. So yeah, next up, we're going to look at making RackMini Profiler show a flame graph for your page. So if you go to this address and notice the query parameter on the end, let me know if anyone if you can all see it and what it looks like. Nelson, any luck? Okay, good. It's working. So yeah, that's cool. You're going to see a pretty graph like I showed you before. It's cool, but it's not super obvious what you can do from there. So let's talk about how we can identify the patterns in a flame graph. So if you've got a big horizontal section that's the same color, which is taking up a lot of space, that indicates a lot of time spent in one method. And a pattern like hedgehog spikes, I'm assuming you all know what a hedgehog is. It's kind of a UK thing. If you can see a pattern like hedgehog spikes that are all the same color, that indicates a loop. Then if you've got a random peak in a different color, that is just changing color from everything below it. That indicates calling out to a dependency. And with that one, those can add up. So yeah. Finally, if you see a big chunk cut out of a flame graph with a flat line at the bottom edge, that tells you that garbage collection is happening. We're about to see this on the next slide. So yeah, this is an example of a big horizontal section. I've kind of like outlined it in a rectangle at the top. This is from what was formerly the third slowest controller action in one of the lists that I showed you earlier. This indicates we're spending a lot of time in one method. And if you see something like this, you want to look at why that is and if it's actually necessary, because that's quite a lot of time. It's like taking up most of the horizontal space. You can also, as I said, you can see you can see garbage collection, which is the light green line at the bottom where literally nothing else is happening in the center. That's garbage collection. So that's useful to notice as well. So yeah, so it might be a good idea to get mics at this point, maybe, if that's okay. Can we get some mics for people? Cool. So yeah, for the next exercise, if you go to this address, I'd like you to try and figure out what kind of pattern you can see here. And when you've got an idea, if you want to put up your hand and we can get a mic round to you. Great. Can we get a mic up here at the front, please? Is that okay? Yeah. Oh, cool.
I was just seeing like a big horizontal.
Yes,
block of
absolutely.
green.
You get a sweet. Thanks, Catherine. So yeah, let's try another. So if you go to /animals with the query parameter, and then see what pattern you can see here. And then again, if you want to put your hand up when you have it.
Seeing a lot of garbage collection with the chunks cut out.
Oh, okay, cool. Nice. Yeah, that's really cool. If you refresh it a couple of times, you might see that change as well. You should also be seeing the hedgehog spikes, so showing the loop as well. But yeah, that's really good. So yeah, with this, you kind of want to think about maybe you don't need a loop. Maybe there's another way you can do this. Is there a more efficient way, for example? Okay, yeah, so for the last example in this section, I want you to just go to the root as I've given here, so just /nothing, and take a look at what you can see. And can you notice any patterns here?
There's a lot of cutting off and a lot of gaps. I'm assuming that's all garbage collection?
Yep. Okay, cool. And there might also be calling out to dependency somewhere there, but I thought it might not be super prominent, so I wanted to show you an example as well. I do want to state something as well for this. The colors of the flame graph are not going to be the same every single time you load the page. That it doesn't really mean anything. It's just, so don't kind of take any meaning from that. So yeah, so this is an example of calling out to a dependency. It's not super clear here, so I've zoomed in. Can you see it? There it is. Okay, so this is calling out to the new relic gem. That is just literally one time, not really an issue. If you see it a lot, look at it. If not, probably fine. You can also click on the flame graph to see the stack trace from an individual frame. So you can see like all the code being called. Another thing you get is a table showing you the percentage of time spent in each gem. And if there's like too much, then look at it. Okay, so I wanted to talk a bit about investigating further. The demo app I've provided you with is not really slow. It's just I found it a good example, and you can also take a look at contributing to it because it's an open source project. That's not necessary for this workshop. So yeah, this is an example from work of a show action. So this was the third slowest controller action in the entire main application. From looking at the flame graph, I saw one of those big long chunks. So that's a lot of time spent in one method. And I found it. So this is in the RFQ class, and the questionnaire method calls out to another questionnaire method in on another object, vertical. So this is really just a worked example. What I did next was I stuck a binding in to the vertical's questionnaire method. And then from that, I noticed that the values passed in for the answers and the two merge parameters in this lower diagram here were identical every time, which results in an identical result. And that meant that most of the time spent calling out from there was completely unnecessary. And I also counted, and the method was called 176 times from the RFQ questionnaire method. So that's like, you need to do that once for the first result, which is the same every single time. You don't need those like 175 or so extra method calls. So yeah, since I knew that call was returning the same result every time, that meant I could memorize the result the first time RFQ.questionnaire was called. So yeah, this is what the flame graph looked like before. Big long chunk, not what you want. And here's what it looks like after. So I'll just go back and forth a little bit. It is better. So we can see the long flat section is no longer there. The big horizontal chunk, not there. So we've eliminated those unnecessary method calls. All right, so that's a worked example. Imagine you've got this file locally. You don't want that to go to waste. I want you to think about how you get that into production. So first up, you're definitely going to be raising a PR, sure. But you can't just put "it is faster" in the PR description, can you? So you want to show locally that the change you've made has improved the speed of the page. So you want to test that change locally. You can use Apache Bench. I've put an example how to run it at the top. Talk to me afterwards if you're having trouble with it. It's a little bit weird. So yeah, you might need to grab the cookie you'll need to make a request. You can do this by essentially making the request in your browser and copying the entire thing out. So I'll give an example of how you do this in Firefox. So you would go in the Network tab, and then you right-click on the request, and then you click Copy Request Headers, and then you get everything you need with the cookie in there. So the results here were from continuing to make the same request that the page makes for 30 seconds continuously, and seeing the average time per request. This is called load testing. You can measure your results before and after your change locally and present them in your pull request. And you could also present the flame graphs and describe the changes evident on these. Cool. So yeah, welcome back, everyone. Hope you had a good break. I know it's the last day of the conference, so there are going to be a lot of pictures of my dog on the second half of the slides. So for the second half, first up, I'm going to talk about adapting your approach, what to do beyond getting your PR into production, and then we're going to really kind of look in detail at flame graphs. Bless you. So We've talked about how to find slow code and get a PR making an improvement into production. And we've talked earlier about the process for convincing your team that it's useful to do this work. So depending on what stage your product is in that you work on, you'll need to adapt your approach a little bit in order to think about making it fast. So in my personal experience, there are 3 stages of dealing with performance within an organization. So I'm going to describe these stages and the slightly different tacks you might, tax you'll want to take in each situation. So you can recognize what stage you're in, probably, and then adapt accordingly. Briefly, these are the ones that I'm going to cover are early stage, rapid growth stage, and the point at which growth has stabilized. So my slides aren't quite right. Sorry about this. So I think I can remember it. In an early stage product, you're probably finding product market fit. Frankly, I think it's unlikely that you will have slow pages unless you've got some very computation-heavy operations. The idea here is that you want to hold the advantage that you have at this point. So in a talk that my old boss, the CTO of CarWow, did about really scaling a startup from very small to a larger business, he said that if you can establish performance targets early on, then that's a really good thing to do. So I think this makes sense when you don't have any slow pages, because then you can decide what you want your goals to be. Then if things start to push out of control, you can then start to address that alongside building out new things. Next up, rapid growth stage of the business. So in this stage, you may know how many unique users to expect at a given time, however, you might not. This can be a very exciting time to work on a product because business is growing and you also get to work on scaling challenges. However, there is a downside. So to talk about this, I'm going to talk a little bit about retail. So in retail, some customers are going to buy pretty much no matter what, but almost. So if they walk into a shop and they know what they're looking for and you have it, they will buy it. So if, for example, if it's raining and someone needs an umbrella, this happens a lot in the UK, then if they're in your shop and you have them in stock, they're pretty much guaranteed to buy that. But you can make a mistake and end up losing the sale. So say you refuse to tell them where they are, you don't have any, they're everyone else has taken them ahead of them, then you're going to lose that sale. So it's kind of the same thing as this. With too much demand, you might not be ready to scale to that volume of traffic quickly enough, or even serve that volume of traffic full stop. So situations this can happen in are you could run a TV ad and suddenly get a lot of users visiting at once, or it could happen around a special occasion that drives users to your business. So, I mean, Christmas could be relevant. It could be some other special occasion. It really depends on the business. It could be in-house marketing. So you send an email to lots of potential customers and they all hit the site at once. Or you could be really lucky and it could be word of mouth or a buzz is building around your product, and so you get a lot of people coming to your site. The problem here is that if you have spent money on trying to acquire users and then you can't serve them, then you are effectively losing money that you can't recoup because they're not going to buy your product. So at this point, you want to start thinking about site reliability. And you also want to start thinking about making sure things are performant under the highest traffic that you get. So yeah, this is actually my friend's dog Wilson, and he's in front of a honeycomb dashboard, so I thought this was relevant. So yeah, this is a talk in itself, and that is not this workshop. And I have actually reined myself in a bit. I do literally have a half-hour talk on this, and I'm not going to do it, but these are the key points about site reliability. But yeah, if you're interested, please talk to me afterwards, because I have got like a lot of opinions about this. So your first priority with site reliability is keeping the site up or your service up, and this is known as availability. Your next priority is preventing slowdowns, and in extreme cases, if it's hundreds of seconds, if your timeouts actually allow this, then that's known as brownout. So this is where your site has become so slow that it actually appears to be down. With this, I would say people have limited patience, and they do expect sites to load in a reasonable amount of time. After that, they will leave, and you won't get the gain in revenue from them using your product. So to work around this, engineers who either specialize in SRE or rotate onto it, depending, they will see a mixture of proactive and reactive work. So proactive work is the kind of thing we're talking about in this workshop. So it's performance optimization, and it might involve planning how you scale your site as well. And then reactive work is the point at which it's too late, you've already got a problem, and you need to deal with it. So that might be a major incident. So what this means is that a major part of your product is failing in a way that affects business. So like homepage isn't working, payments isn't working for all users, that sort of thing. That's obviously bad, and you don't want that to be happening at your work for a very long time. So that's the kind of reactive work. There's also triage, which is another aspect, which is essentially handing out bugs to the teams that can fix them. Another thing here is you can have put in place performance targets or service level objectives, which are those sort of performance targets that I discussed before. So those are either, okay, so basically like these are targets that you agree with your product manager or other stakeholders for how quick you want your product to be. And essentially like these, you kind of agree these and you decide where you want to be from where you start at. And then if you aren't meeting these, then that kind of gives an importance to prioritizing work to deal with that. So for example, I mean, this is an example, so don't take what I'm saying as like something that you need to make an alert of. But for example, you might say, and you want to be talking in averages, you might say if the homepage, we want it to take 1 second or we want it to take 3 seconds, your decision. And then if that's for all users, on average, taking more than that for a distinct amount of time, then you want to alert one of your engineers to take a look at it. That's it. I'm not going to do a half-hour talk on this. That's it for now on site reliability. So yeah, I talked about 3 stages. When growth has stabilized, this is another stage. So when growth has stabilized, there could be a really nice reason for this. It's super unlikely, but you might have gained the entire market for your product. I do find that very unlikely. Otherwise, you have some kind of competition. So for an idea of how quick you want to be, I would recommend you look at your competitor's product. So Jonathan Nightingale talks about this idea of getting a better understanding of the business that you're in. And you can do this from a performance standpoint as well. Incidentally, he wrote a book with his wife, Melissa, and it was recommended to me, and I'd recommend all engineers read it. I've put the front cover up on the slide. So whatever type of product your work is in, what you would do here is you look at your competition, and you get an idea of how fast their site is by visiting their homepage, going through their sales funnel, and then obviously if the final step is paying, you don't actually have to do this. Like, it's not necessary. But then this gives you a good idea of what you want to be aiming for. You don't need to be exceptionally fast to start with. You just need to be a bit faster than your competition. Because it's possible that your competition is slow enough that people get bored and start looking for other options. And maybe that can be your product. This is also a good point at which it might help to think about bringing down your server costs, but I would talk to people on your team and see if that's a priority before you do that. And that you can do from this kind of work. So yeah, we're pushing on. So we talked about how you raise a PR, and I'm going to assume you've gone and done this. So I'm going to talk a little bit about the concept of marginal gains, staying in the lead, which I've already sort of talked about, and bringing your team along with you. So something I've observed is that with work like this, you can make an impact doing optimization work on your own, but after a few PRs, you're going to find that there's only so much impact you can make on things. So as we discussed earlier, we're kind of assuming there's only so much time you have to spare for this, because there's other work that you have to do. So you are time limited on this. So in the long run, I would say you're going to have more of an impact if you can get other people you work with involved. So yeah, marginal gains, just briefly, concept taken from sports science. The idea is that when you want to speed up, rather than trying to make huge, massive changes with respect to speed, you can make little changes, lots of them, and those add up. This ties into working with your team and bringing your team along with you. So say, for example, you have hundreds of slow pages. It would be super inappropriate for one engineer to try and fix all of them. So if you can get other people involved and try and make little improvements for each one of those, then that can add up to a massive improvement over time. OK, so moving on to the flame graphs detail section. So in this section of the workshop, we're going to learn more about flame graphs. We're going to look at how they're invented and some alternatives for visualizing profiles. Then finally, we'll do an exercise where you can get into profiling your own apps. Cool. So why do we need flame graphs? So to explain why we need flame graphs, I'm going to show you an example of just one of those stack traces. So you've seen this one before. If you take a look at this, there's just lines and lines of code. This is for one point in time only. So if you were going to try and get information for an entire request, just for one, you would have to get every single stack trace for every point, for the points in time for that request, and try and read them yourself, and then figure out from that manually what's going on and where time is being spent. And I don't know about you, but that's pretty much impossible for most people. So this is actually the reason that flames graphs were invented. They were invented by Brendan Gregg, who I think is at Netflix at the moment. So in an article in 2016 announcing flame graphs, he wrote, "The output of profilers can be verbose, making it both laborious to study and comprehend." He then explains how flame graphs can be used for much faster comprehension. If you want to read the paper, that's the link to it. OK. So we've established why we need flame graphs and how they're invented. Let's look at other ways that profiles can be visualized. So first up, what we call flame graphs in Rack Mini Profiler and in most writing about Ruby performance are not actually originally what were called flame graphs. So earlier I mentioned how the x-axis of a flame graph represents the time, but actually when he coined the term, Brendan Gregg was calling a flame graph a visualization where profiles are sorted alphabetically. So that's actually the first alternative way of visualizing profiles, flame graphs. So yeah, what I've been calling a flame graph was first called a flame chart. I've kept it this way in this workshop because this is what they are consistently called in Ruby, and I just thought it would be very confusing otherwise. However, if you look outside to other languages and Google for it, you might notice this term instead for visualizations of profiles sorted by time. Sunburst charts take the same information as profiles sorted alphabetically, and they wrap it around in a circular graph. They do look very nice. I'm not sure they're super easy to get information out of, though. The last type I'm going to cover is Icicle Charts. So if you think of a flame graph as starting at the bottom edge of your graph, like that, an Icicle chart flips that so that instead you've got the information hanging off the top edge of the graph. Which format you find easier to read is quite a personal thing. And interestingly, we are now going to see that the new the new visualizer for flame graphs in Rack Mini Profiler uses an Icicle layout. So, the eagle-eyed among you may have noticed in the setup instructions that I locked Rack Mini Profiler to a specific version number. This is because it has started using a different renderer, Speedscope, for visualizing flame graphs in the browser. So Speedscope was designed by Jamie Wong to be a language-agnostic renderer that's more performant than other options. More performant? That seems weird. Like, the flame graphs we looked at earlier loaded pretty quickly, right? So, like, why did Rack Mini Profiler need a new renderer? Right. So for slow pages, so for example, I ran a profile for a page that took 10 seconds to load when I started. I did this before the new renderer was introduced, and the browser tab would like crash quite a lot. I wanted to introduce you to reading flame graphs. I find it easier to get the whole picture if you can see the whole flame graph in one thing. But realistically, you could be looking at some pretty large profiles, and there's every chance your browser tab could crash using the old renderer. So I want to introduce you to using Speedscope instead as well. Right, so what I want you to do, this might be difficult on the Wi-Fi to be fair. What I want you to do is to stop your Rails server, check out the branch Speedscope renderer, and bundle install again. Once that's completed, I want you to start the server up again, and then navigate to localhost 3000 with the query parameter for flame graphs at the end. And then tell me what you notice.
I guess what it looks like for me is there's most of the screen has like a few pastel bars, and then the left is like this really smooshed area.
Yeah.
That's kind of hard to read, but
Cool.
That's what it looks like for me.
Nice, thank you. So yeah, it's a different view entirely. The flame graph is upside down. You can zoom using the plus or minus keys. You can't zoom out to see the entire graph in one go. You don't have the percentage of time spent in each gem in the layout as well. Don't worry if you've not got it working. Like, we'll see some examples as well. So Rack Mini Profiler started using Speedscope in December 2020, and there are a few differences between Speedscope and the old renderer, which was Sam Saffron's flame graph project. So firstly, Speedscope has been designed for performance. Like I said, we haven't seen an example of this in the exercises, but for pages where there's a lot of information, just a lot, the old renderer can crash the browser. I've had success, if you can call it that, shutting down everything, opening one tab, restarting my computer, and just being persistent. But I don't think you really want to do this, and it can waste a lot of time when you're already time limited. So Speedscope will render flame graphs for these kind of profiles without any problem. Yeah, you'll notice the graph is upside down, so that's the Icicle layout. I do think it would be cool to support both the Icicle and the flame graph layouts, and that's something I would personally like to look into. You can also see other options as well. So we're going to talk a little bit about these, and then I'm going to get you to take a look at these yourselves. So I'm going to talk about the left-heavy view, the sandwich view, and the export and import options. So the first additional option in Speedscope is the left-heavy view. This groups stacks which are the same together, and it means it cannot sort along the x-axis by time. Instead, it sorts each group so that the biggest stack for each group is on the left, so therefore each group is left-heavy. So you can see where the slowest code is running. Next up, we have the sandwich view. This is a little bit like the percentage of time spent in each gem table from the old renderer, but it's done by individual methods rather than by gems. Finally, there's some very nice export and import options in SpeedScope. So in the top right of the view, you will be able to see an export button. This exports the profile in a JSON format. So I've put an example on here of the format that it exports in, but you can learn more about the format in the SpeedScope docs, which I will link to. Also, because SpeedScope was designed to be language agnostic, you can also import profiles for lots of different things. So Chrome, Node.js, instruments for Apple operating systems, Haskell, .NET, there's a lot of options. You import these using the import button in the top right corner of the UI. So for this exercise, I basically want you to play around with SpeedScope and take a look at the other options. So if you've not got stuff set up, like try and pair up with someone who has. And you can do this on the root or one of the other pages. So I'll give you a couple of minutes. Just try looking at the left heavy and the sandwich views, and try exporting a profile to JSON. OK, cool. Hopefully everyone's had a chance to take a look at those options. If not, you can take a little look after as well. So yeah, I'm just going to recap. So we talked about reasons we care about performance in our applications, how to prioritize and rule out other causes, how you read flame graphs, looking at changing some code to speed it up, and getting that change into production. I've talked about adapting to what stage your work is in, and the history of flame graphs, the SpeedScope visualizer, and where it's most useful. So yeah, the final exercise I'm not going to pause for, because this will be after the end of the workshop. But I want you to install Rack Mini Profiler in a personal or a work project that you'd like to take a look at, and then check it works locally, and then go through the steps that we've talked about. I'll share the slides afterwards as well. And then you just want to see if you can find something to speed up. So yeah, I'm going to stay on for a bit after as well. So yeah, if you need help, do let me know. So yeah, references. Once you've found these areas that are slow that you want to speed up, other people have written very good material about how you approach this. I want to do a particular shout out to Nate Berkopec, because I've been following his stuff for years, and he's written really well about this. These are my references. References continued. Even more references. So yeah, thank you very much. You've been a great audience. I'm Jade Dickinson, _Jade Dickinson on Twitter. And yeah, I want to hear from you after. How did you get on? What did you find? Did you change something in the application you picked out? And I'd like to hear about results.
Hi. Have you done any stress testing with these techniques as well, where you're generating a lot of traffic artificially to see where things are slow?
OK, so yeah, so a friend of mine has written a very good article about doing this. It's an open source project. I'll just try and get the details to you, but it is essentially doing shadow requests and, like you said, just making fake traffic to a site based on, this really cool because it's based on real traffic. It's called Umbra, and if you go, I think, github.com/carwow/Umbra, I think that's the repo. This is off the top of my head, though, so yeah. Cool. You're welcome. So yeah, thank you very much. Hope it's OK if I take a picture.